So a soft drink company is conducting research to select new design for the can. A random sample of 75 participants were selected. So the 75 tells us our sample size. And then instead of a typical taste test with two different sodas, they actually give each participant the same soda twice. One drink is served in a predominantly red, and the other is served in a predominantly blue can. The order is chosen randomly. Participants are asked to rate each can on a scale from 1 to 10. Thus, the company wishes to test if the color of the can influences the rating. The rating is recorded for each participant. So this tells us that the results are paired together. They want to know, does this sample indicate that there's a difference in the taste rating? So since they're paired, we have one categorical variable and one quantitative variable. We're going to do a paired t-test. So the first question wants to know, what type of test would the company conduct to determine if the color influences the rating? Then the correct answer would be a paired t-test. Because all we're going to do is we're going to take their rating for the red can, subtract the rating from the blue can. That's going to be our difference. And then we're going to take just the average of all of our differences. So we're going to know, what is the null and alternative hypotheses? Anytime we're doing a pair test, our parameter of interest is mu d. So our null hypothesis is going to assume that there's no difference based on color, and our alternative is going to assume that there is a difference based on color. Because that's what the question is asking. Is there a difference between the two? So the correct answer would be D. Then wants to know, if the test statistic is negative 0.739, what is our p-value? So it's a paired t-test, so we want to draw our t-distribution. Our test statistic is negative 0.739. Since it's a not equal to, that tells us it's a two-tail. So we also want above positive 0.739. So we want the upper tail and the lower tail. So we're going to go to second vars, TCDF. A lower bound is going to be some large negative number. Upper bound's negative 0.739. Our degrees of freedom, we have a sample size of 75. Since we have 75 different differences, then our degrees of freedom is going to be at 75, lose 1. So degrees of freedom are going to be 74. So the lower tail is 0.231. Our upper tail is also going to be 0.231. So our p-value is going to be just the two added together. So we get 0.462.